Okay, so now for the demo for Autonomy AI. So with Autonomy AI, just like all the other workflows that we have in Amber, you launch it through the ribbon. So you find it in the workflow gallery, and it's here under Autonomy AI. So you just click on that, and then that will load. And you're greeted by this user interface. And what this allows you to do is the first thing you do is you do a trip selection. So you select your trips. Now, the different options for trip types are you have VSIM, AIMSIM, Sumo. So those are your micro simulation tools. Then you have your mesoscopic simulation tools, such as Polaris. So these are all predicting some form of traffic flow, average speeds on links, link speeds. So you can do an experiment where you set up a configuration, you set up a simulation, network of roads, a corridor, you set up your street lights, and you set up your timings, you set up your traffic conditions or initial conditions, you let that simulation run, you record the traces that come out of it, the average speeds, and then you run that through a tool like Autonomy AI to add the energy use or the energy consumption. So in this case, what we'll do is we'll show results from the autonomy cycles. So what I'll do is I'll select autonomy cycles, and then I'll go and browse for a folder here, and I will browse for under libraries, common cycles, vehicle. There's a set of certification cycles that I could select. Then what I'll do is I'll load the data for those certification cycles, and we could see that the characteristics load in the grid. The characteristics that load in the grid here are the ones that the neural network was trained on for predicting energy use, for predicting fuel economy. So what you're seeing here are the statistics for those cycles. So minimum speed, maximum deceleration, maximum acceleration. And you could see over here that the boundaries, if your cycles, if the polygon for your cycle falls within this polygon defined here, then you could be certain that the neural network is predicting accurately for your drive cycle. If you fall outside of it, especially if you fall far outside of it, then you know that the level of confidence that you have in those simulation results is going to be lower because it wasn't trained on cycles of that type. So we could see here the cycles that were chosen, mostly certification cycles. So because of that, they fall within the range that the neural network was trained on. So on the next tab for vehicle selection, what we'll do is we'll go and select a set of vehicles. I'll select some compact vehicles. So there are vehicles here, full auto. So I'll select that. And then I'll also select maybe some mid-size vehicles under BEV. So I'll make a selection of those. So we have, say, 22 vehicles here. You can go and modify some characteristics. So if you want to go in and you want to modify, say, the rolling resistance of the vehicle, you can go through and modify the rolling resistance. So if you're saying, okay, my vehicles in the future have better tires or worse tires, you could make modifications here. If they have better or worse frontal areas, you could do the same thing. Electrical accessory load, you can modify the electrical accessory load to see, oh, okay, my electrical accessory load, I have a more efficient air conditioner, I have more efficient electronics using some ARM-based processors and my onboard electronics, something like that. You're using less energy consumption. You can modify the electrical energy consumption based on your scenario. Then you could save that out as a vehicle set file, and you could reload that later. Once you sort of define the vehicles you're going to run on, you've done your cycles, you've done your vehicles. Now what you're going to do is run all those cycles on all these vehicles. So you go to launch, and then you launch Autonomy AI, and then now rapidly go through and make predictions. So if you compare the speed on a per vehicle per cycle basis, if you're running autonomy, it's a full version of autonomy, it has to build a Simulink model, it has to configure the Simulink model. It will take up to a minute to run, depending on the type of cycle that you have. You can make that much faster if you end up, compiling the model. But in this case, what you have is you have a much faster version of it that has been shown to accurately predict fuel consumption and electrical consumption on these vehicles. So in those cases, you have this rapid, significant speed boost that makes this feasible. Because we're able to run Autonomy AI as fast as it does, we're able to run a lot of different scenarios with the output from the transportation tools that we were showing there. Where you're running your Sumo, you're running your vSim, you're running your AIMSIM, or you're running your mesoscopic tool in terms of Polaris to make cycle predictions. So here we have the results that have loaded. So once the results have loaded, we could look at things such as electrical energy consumption, and we can group by, say, model year, and we could show the electrical energy consumption as a function of model year, and you have your max and your min and your median and your quartiles that are present there. You go to your aggregated view, same thing, same concept here. We could group by model year. In this case, you just get the number of, say, powertrains in each one of those categories. What we can do, though, is we can add here something like electrical energy consumption, and we can add the minimum. We can add the maximum. We can add the average. So we could add those to the chart. Now you could go through and analyze and look at the results that you're getting for each of these categories of vehicles. You can also sort based on the average electrical energy or any of the other parameters. So you could sort ascending. So you see that in 2050, you're getting the lowest energy consumption. And then if you sort descending, you get the highest energy consumption, say back in 2010. And you have other plot choices too. If you have if you prefer a line plot, you could show a line plot. If you prefer area, you can show an area plot. For this, we'll just leave it on column. There's also a time view. So you can go to time view and you could actually see the results for each one of the simulations. If you click on here, you can go through and see, oh, okay, this is the result for the electric 400 2015 vehicle on an LA92, SC03, US06. So based on the cycles that you choose, you have an entry here. You could also filter if you want to just, filter down to the FHDS vehicles. You can filter down to that. If you want to, say, filter based on time frame also, you could filter on time frame. Look at just these vehicles by themselves. Then there's also a grid view you can go to. So a grid view, same thing. You could look at the results here and filter the results. And depending on what you filter on, you could save that to Excel. So I'll go here and I could save, this as an example Excel file, load the file in Excel. I could save a CSV file, same thing. I could go here and save a CSV file of the results. So that's pretty convenient. And it only shows what's here in terms of the actual results that we're looking at. So if I go to Amber, and this is the development version, I go to projects, default. Now you can see the results are saved, the vehicles are saved out to a file here, along with their initial inputs and the results. You can also do things such as, if I clear this filter, you can group. So if I wanted to group by model year, so I have the table and I want to just have them all grouped by model year to look at the statistics over a model year, I can drag and drop it here. So I see 2010, I have the values for the model year, 2015. I could go in and see, more detail on that model year, why the minimum is what it is, why the maximum is what it is. I can also do things too, where if I wanted to, I could, further sort it by vehicle class. So I could drop vehicle class on here, and now I have it, like sub broken down by vehicle year, but then also by vehicle class. So now I have the vehicles that are associated to compact in here, and I have the vehicles that are associated to midsize that are also in here. So this is a very convenient way to, analyze results, save out some of the analysis that you've done, but in general, be able to take the output from your transportation tools as a transportation modeler and blend the best of what a powertrain engineer can deliver in terms of accurate vehicle energy prediction with autonomy, and use that with transportation modeling tools and the output from transportation modeling tools by using Autonomy AI.